going to use the two different amp probes, the PDI, which can go on a Modus or any banana type meaning a little plug-in, or you can get this little piece here from AES that converts a banana plug into a, and I've got the name of it. I'm thinking of USB, it's not USB. A BNC, I'm sorry, had a brain fart there, into a BNC. And the plastic ones are better because the plastic ones will not rip the top up. If you have a metal one and you're using it on a scope like this, you'll rip the top right up. So we're talking about the little plastic piece here. And that is important when we're looking on a high voltage type circuit, whether diesel injectors and or new direct gas injection, and of course hybrids. The next thing you need to know is how to set the amp clamp up. So let's move on to that and move to the next slide. Now, if you have the inexpensive clamp, and I don't know how many of you do, could we see maybe a set of hands out there if you own this clamp?
On participants, just click the little hands. We'll be able to see if you have an amp clamp or not.
So just click your clamp. This you could get from AES Wave, www.aes Wave. They're inexpensive. We also have them through TST as well. This clamp has a little bit different writing here for 1 MV equals 10 MV and 1 MV equals 100 MV. So that could be a little bit of a problem if you don't know where to set it. There's different resolution. This amp clamp has also two settings, and what we like to put it on here is 100 millivolts equals 1 volt, or in the case 1 amp, because we can convert it. We're not doing direct amperage, and what I mean by that, we're not doing direct amperage. We're taking voltage readings from these amp clamps, and basically what we're doing with them is we're converting this into an amperage reading. You'll notice on your slide that the little sticker at the top is 10 millivolts equals 1 amp, or 100 millivolts equals 1 amp. You want to go to this setting right here on these type of amp clamps, PDI. You'll notice in the slide, we tell you to make a little piece of tape here so you know where to put it. And 100 millivolts will give us the best resolution. That is super important. If you don't have good resolution, we'll run into a problem. The other thing on this amp clamp is we're going to need to know how to zero it. Be careful on this amp clamp, this button sometimes sticks. Also be careful that the jaws, and if you can see in there the metal jaw, right there, the jaw right here could have metal filings. Sometimes people put them down on their tool cart, and when they're down on the tool cart, maybe some brake dust or other debris, and that'll give you a bad reading. On this amp clamp, when we put it up there, we need to zero it a different way with this dial, and we'll do that on the scope. So we would need to turn the dial, a little bit of an old-fashioned. This is a more accurate amp clamp, but basically for what we're testing, this thing is approximately $450+. This one is about 110 or so. So you could break a whole bunch of these compared to that. Now again, some of you bought the special ones for the Modus. Well, if that's the case, then when you set it up, we'll talk about that. You'll be setting it up to the amp clamp setting. Every other scope, we're going to set these clamps up to voltage settings. And that is important. Does everyone understand that? We're going to set them up to voltage settings.
Two things. First of all, that PDI unit comes with either a male or a female banana plug, so you may need one adapter or the other. Secondly, you sometimes have to snap the probes, the clamps together to get rid of the static charge. And
what Pierre is talking about is doing this, static charge. Clamp them, make sure there's nothing in the drawers. And what he was also mentioning, and we have Pierre remotely tonight. He's the vice president of TST. He was talking about these could be different. And again, you always want a plastic BNC. If you have the E-scope, that is a little different. It has metal ends. But you could buy this if you were doing anything with high amperage. This is a little safer. Okay? And again, AES makes these and sells them. I forgot how much they are. It's roughly about 25 bucks or so. At any rate, the other thing very important on an amp clamp here is what? The battery, the 9-volt battery. If the 9-volt battery is weak, all your readings may be wrong, and that'll be a big problem.
Alan asked, when using a CA-60 with Fluke DVOM, and I set it to the most sensitive position, I was told to multiply my reading by 100. I get a decimal fraction reading of 0.450. Do I multiply my reading by 100 to get my amperage value?
Okay, now he's doing that on a meter.
If you read 0.45, what is the value?
I'd have to see that. The clamp, what clamp number does he have?
A CA-60 with Fluke.
CA-60. That's probably a big amp clamp. What you may want to do is email me the number of the amp clamp and what meter you're using it on, and I'll email you that back. Because off the top of my head, without seeing it, I'm not sure. I don't know that model off the top of my head. I know their low amp clamp is an ADI-110.
Tony says change the volts.
Well, you can change the volts down to millivolts, but again, you still need to know if that clamp, you see like we have up there? Look on the current screen. The settings are different. The readings are very similar, aren't they? And if you look at the readings up there, you're getting a finer, better reading at 100 millivolts equals 1 amp, okay? That's the reading we're on. So you're getting 450 millivolts, not 450 milliamps. Here, you would have a little bit problem reading that. It's not as precise. You have more numbers, okay? So if this clamp is not rated, whatever clamp you're using is not rated at what these low amp clamps are doing, you're going to get a totally different reading. So that's why you need to know what the clamp rating is. Most of the clamps that have big jaws, bigger jaws than this, the big round one, and I'm going to show you what I mean. Hang on one second. I do have it. To give you an idea that it's not a low current clamp. Okay, here's a big clamp. You see these jaws? A lot of times the tool dealers, rather than selling you the small versions, this is a PDI big one. This is for a starter draw. This would be for something big, high amperage. The ratings are totally different. And if you look here, it says 600 amps maximum, and they want the output 1 millivolt equals an amp. So you'd have to go on millivolts on your digital volt meter. So go to the millivolt scale, and then if you have a clamp like this, let me put it this way, and every 1 millivolt equals 1 amp. And of course you could read a lot of millivolts on your machine. And then you could also go into voltage. Okay? Hopefully that answers your question. And you can still email me if you'd like. Once you set your scope, every 100 millivolts equals 1 amp. So what we're looking at right here, that's my 0, 1 amp, 2 amp, 3 amp, 4 amp, 5 amp, 6 amps. I change it to 200 millivolts per division. Now it's 12. I change it to 500 millivolts per division. We would go 5, 10, 15, 20, 25, 30. You would just count it up, whatever the difference is. So from 6 amps, you can go to 12 amps, you could keep going, you could change the value to 1 volt. And then 1 volt is going to equal 10 amps. Okay? 2 volts would be 20 amps. And then you would go 20, 40, 60, 80, 100, 120 amps. So that's what to do, and that's what that means. So let's wrap this up here and go over how we can easily find components that are bad components that are bad with an amp clamp, we're merely taking this clamp and all we're doing is going around the wire. It's pretty easy to do. This is not hard. It takes a little practice of getting used to your scope, setting it up. Remember, every 100 millivolts equals 1 amp. If you're on this type of amp clamp, you're going to go to 100 millivolts. If you're on the PDI, you're going to put the little tag on there, and the little tag on there, you're going to go to the first markup from 0, which is 100 millivolts equals 1 amp. If you have your snap-on amp clamp, the expensive one, you're going to have to go into here, and rather than voltage, where it says test leads, you're going to have to go up, and you're either going to pick 20 would give you the best resolution. Let's see, we'll just try to get that straight there for you. 20 would give us the best resolution. Got a good shot, Craig?
Mm-hmm.
And 40 would give you a little less resolution. You would pre-pick that, and what it would say is low amp clamp, and you would be then going over and adjusting how much amps you're going to read on the scale. Whether it's going to be 20, 10, 20, or 40 for the whole screen, and that's on the 40 amp clamp, or if you went to 20, you go over and you see that it's finer. 500 milliamps for the whole screen, 1 amp, 2 amp, 5 amps, 10 amps, and 20. That's the one you're going to want to use for injectors, ignition coils, fuel pumps. That's the baby you want if you own the snap-on amp clamp. Again, everything else would be on voltage. Now here's the important part. You set this up. I told you every 100 millivolts equals 1 amp. Okay? So if you start going up, we could start counting how much amperage it is. Let's do this on the scope. We'll first go over and use the Fluke scope. And what I'm going to do here is I'm going to trigger this so we get a steady reading. I'm going to go to the fuel injector. I'm on the fuel injector, and you can see we got a voltage reading. As voltage goes down, goes near ground, there's my A. I have my B channel right underneath it. That's the blue one. First thing I need to do, super important, is move this up to 100 millivolts. Got a good shot of that? Have to move it up to 100 millivolts, which is going to equal 1 amp. The next thing I need to do is click the jaws. Okay, make sure there was no debris in there. And now we need to zero it. So I'm going to play with it. Look at the blue line, and let me move this out of the way. Of course, cooperate, there we go. Watch the blue line on the screen as I turn it. Could you see that it went down? Could you see that I'm now above the A? Okay, and I'm moving up. This would change my reading. Look where 0 is. 0 is the line way on the bottom. Okay? And maybe just to make it a little easier, let me move that B line up to this line here. Right under the system voltage. Remember when a fuel injector comes on, that's going to be about 14 or so volts. It should be your charging system voltage. If that is low, if that's at 12 volts or under, then guess what? You got a charging system problem on that car. You should come all the way down to ground. 100 millivolts or less voltage drop, and your peak should be 35 volts or more. In this case, we're up there 10, 20, 30, 40, 50, 60 plus volts. But let's zero the clamp in. We're here for current ramping. So I'm going to move this down. And notice, as I'm turning the dial, look at where the line is right there on the B. So right at the B, I'm zeroed. I'm going to click this. You see the line going up and down as I click it? We want it to go back down to 0. You don't want this near another power source, meaning if you have those old metal drop lights, you definitely don't want it near that. That's a definite. You don't want it near a battery that's charging. You should never charge the battery with the cables connected anyway. but please make sure that there's nothing around. Now, what I'm going to do is I'm going to go to the fuel injector over here. And again, you'd be doing this on the car. On the car, you would be back probing your voltage here. And it doesn't matter with an amp clamp, whatever wire I go on. I'm going to go on the white wire, and now I'm going to want you to take notice of the reading. What do you know? The reading, if I get the wire out of your way, the current is actually down, isn't it? The current is low. It shouldn't be low. What's happening here is my amp clamp is either upside down, so I could do one of these, I could flip it the opposite way I had it, and now you'll notice the current rises, doesn't it? So again, the current went up. I flip it, it's down. Now I'm going to go to the other wire just to show you it doesn't matter what side of the fuel injector I'm on with an amp clamp. Not with the voltage side of the scope, but with an amp clamp. So I'm going to go here to the red wire. My scope lead would be here. Now notice, look back at the labscope. The voltage is correct. As voltage drop, amperage starts going up, doesn't it? Now, notice how the amp clamp is sitting on the red wire. You see how I have it this way? I'm going to flip it the other way, just to show you it does not matter what side you put it on, but what's going to happen now? The current is going to go downwards. It's just going to be reversed. So to wrap it up, you need to trigger off the negative side of the injector, okay, or the coil, or a fuel pump. It doesn't matter. You need to go off the negative side. That is important. You could flip the amp clamp over anywhere you want. That doesn't matter either. Now, some people, I will warn you, play the trick when they're using this type of clamp. And what's the trick? Well, if I have negative and positive on and it's upside down, well, I just unplug it rather than going under the hood of the car and switching the clamp around. So I went from red to red, I went red to black and black to red, and I switched it. I'm going to warn you, that may ruin your readings. Your readings may not be accurate because it will change the zero of the clamp. So please be careful if you're going to do that. Your best way is flip the clamp around. And believe me, I know working on cars that sometimes it is super hard to get this thing in a spot. You worked hard. Never ever do this. Why don't we go around two wires? Who knows? Look what happens when we go around two wires. You're canceling the signal out. Never go around shielding. We have some of the plastic or it's taped up or whatever. People like to go around it. If you go around something that's shielded or taped, guess what? It's not going to work. So you need to go to an individual wire as long as it's on that circuit.
I would like to add something. You can go to the plug for, say, a main relay or whatever power supply those injectors have. However, if they're backfired, you're recording the amperages with all of them. It only really works on one injector at a time.
Yeah, it only works on one injector at a time. Another problem people have, let's say you have an 8-cylinder vehicle. You're triggering voltage off injector number 3, and you want to check the amperage on injector number 1, your readings won't line up. In other words, what's going to happen is the voltage is going to be here, and you may not see the amperage. It may be in a different spot, okay? So you need to trigger the voltage or trigger off something that is exactly lined up rather than spread apart, okay? Let's take a look now at the scope. Let me flip this back correctly so we got a right reading. And because this injector does not have any fuel pressure behind it, this is important, I want you to notice that my setting is 100 millivolts on the blue one. 100 millivolts equals 1 amp, so each box And let me move this up now. It'll be easier to see right here. You see I'm here, 0 at that box? I'm at the line at 0. This box or next line would be 1 amp, 2 amp, 3 amp, 4 amp. Well, first of all, the normal for a saturated drive injector, what's a saturated drive injector? Most common ones used on a vehicle. It's not a throttle body injector, and we'll go into that a little later. A saturated drive injector is something that has about 15 ohms of resistance. Now you can't go by resistance. Why? You could have good resistance of injector, meaning the coil windings, they're all good. There's not one of them that is shorted or broken, it's open, where you get an OL reading. But what you don't know is the pintle could have a mechanical problem. The windings are good, but the pintle is bent. If I have mechanical resistance, amperage will go up. Does that make sense? If I have electrical resistance that's lower, amperage will go up. The thing that you should all write down right now, what's going to burn a computer out on a vehicle? What's going to burn a computer out on a vehicle is anything more than 1.2 amps for more than 6 milliseconds. Very important to remember that. Anything more than 1.2 amps for 6 milliseconds. That will burn a computer out. Now, why do I say that? Well, you ever look inside of a computer? There's no big, heavy wires inside of a computer. They're all little wires. They can't take a lot of current. Everything runs on low current. When an injector comes on, as long as that injector doesn't stay on too long, you will not burn the computer up. For argument's sake, we'll talk about a peak and hold injector. A peak and hold injector can pull anywhere from 4 to 5 amps, depending on if it's a GM or a Bosch style one. And then it holds at about 900 milliamps. That's most common on a vehicle. 900 milliamps to approximately 1 amp or so. Again, got to be on the 1.2 amps. But a peak and hold, when it first comes on, I just said pulled between 4 and 6 amps. Excuse me, I said 5 because Bosch would be the 6 ampage, 4 to 6 amps, and then it holds at 900 milliamps. So that only happens for a few milliseconds. 1,000 milliseconds makes 1 second. And 6 of those milliseconds or more that thing will pull, that high amperage, would burn a computer up. Okay? But again, you won't see that happen. Pulse modulated, one of Pierre's favorite cars there, BMW. Some Porsches, some Mercedes, some high-end type sports cars. What that injector does is a little different. It's called pulse modulated. It goes on, it goes to ground. That can pull anywhere from about 6 to 7.5 amps. It goes on, and then it goes, that's at about 900 milliamps. So it has a very hard, good ground. It comes on fast. They ground it real well. That pulls, again, 6 to 7 or so amps, and then it modulates at about 900 milliamps. And that's the circuitry inside the computer that actually lets it pulsate like that. This standard or conventional injector goes on, and then it goes off. Peak and hold goes on, and then it switches lightly to what we call the hold circuit. That's the 900 milliamp circuit. So let's take a good look here. You can see we're under. Why are we under the expected amount? If we measure that out, that's probably about 700 milliamps. You would more likely find it right under that box. If you're blind like me, how do we blow it up? How do we make this look bigger, the blue? Well, you come down to your scope setting, and again, we're going to do this right on the motor, so don't worry. We're going to make this smaller. Now notice how this got bigger. Why? I made it 50 millivolts. Okay? So each box is 50. 2 of them equals 100, which equals 1 amp. Remember, we don't change anything on the clamp, and we're using the other clamp there, okay? We don't change anything there. Every 100 millivolts equals 1 amp. So I made it 50 millivolts. And that would be 50, that would be 100. You can see we're not up there. If you're real blind, you go one more. Now look at it. Now you can see the pintle hump right around on this particular injector little less than 50%. Usually 50, 60% when you got fuel pressure behind it. Newer injectors, unlike the older ones that had one little tip, sort of like this pencil, they're multi-tip injectors, and you don't see the pintle bounce as much anymore, and that is called the pintle bounce. And just to recap, if we put the voltage higher, the picture gets smaller. Every 100 millivolts equals 1 amp. Let's move on. When we do an injector, we said we go to either side. Now on a peak and hold injector, you start coming up. Here's where you pull the highest amperage. You go down, here's where you pull in the 900 milliamps, and then you go back down to ground. And again, doesn't matter what side you're on. Click the jaws once again, make sure they're clean, go only to one side. Do not go around both wires or any shielding. You can see here, look at the difference in these injector waveforms. Look at this pintle compared to that pintle. Neither one of them are bad, they're both good, they're just different. Remember, you may not see big pintle humps like this anymore with multi-tip injectors. Click. Here we give you the whole idea of sequential injectors, the hot side, just like the coils, right? You don't need 5 clamps here. You go here where it's easiest. Why? If it was expected that each one of these pulled 1 amp, or 1.2 amps max, 1, 2, 3, 4, 4.8 amps, you're pulling more, you now have to go on each. You're pulling less, you go on each of these to find out where the problem is. Click. Here's a peak and hold that took years back, okay? And this one here is off a Chrysler product. It goes down to ground here, real tight on voltage, comes up, has a clip top, it's flat, comes across, goes up. Here's the amperage. The amperage goes up real high, goes to about 5 amps, comes down, goes to about 900 milliamps, and then it goes off. Only from here to here is the amount of time that the injector's on. You can see it in amperage as well. Click. Here we have a problem on a car, peak and hold. This is a GM peak and hold. Here's a good one. There's the amperage goes up, comes flat across. This is the voltage here. Okay, the voltage does the dip down and up. Look here what happens. Look at the ringing. Right there, the amperage, the voltage went crazy. This injector and the computer were bad. Very common problem on peak and hold. Go ahead. Doing some output tests. When you want to test an actuator, it's okay to use your scan tool, and if you have a meter, you could check the amperage, couldn't you? It's really not that hard to do. All you need to do is set that up. You could use a labscope, obviously, as well, but we could do this bidirectionally controlled on an actuator. Click, and you go through the ATM test. So here, we show you the both of them. We either go this way with a scope, okay, or we go this way with a power probe. Remember, the PCM is nothing more than a very expensive fuse, isn't it? It's the most expensive fuse in the car, because when a solenoid, you see the windings in here? When the windings get shorted, excuse me, low resistance, high amperage, anything more than 1.2 amps for 6 milliseconds, poof, the fuse blows, the computer, the most expensive one. You put another computer in, guess what? Poof again. Because why? You have a solenoid that's pulling too much amperage, burning the circuit out. Look here, 500 millivolts, 5 amps, 10 amps, 15, 20, 23 amps. This was a evap solenoid that was held on with a power probe that winded up burning the protected fuse inside because it wasn't rated for that. We held it on and burnt it up, and we were able to get it fixed.
Spear.
The concept is, just to review, amperage is work being done. It changes, it doesn't change through the circuit. Voltage changes through the circuit as the work is being done.
Right, and these are just conversions. This is not really showing you amperage, it's voltage conversions to let you see amperage. Your scope is not going in series like we would use our digital voltometer to measure amperage. Does everyone understand that? Just a conversion. Okay, let's move over to the motors now. Okay, so we have our fuel injector on there voltage-wise. Notice on my green, that's channel 2, that's this amp clamp. One of the things you want to do is, number one, make sure you put this on and every 1 MV 10 MA equals 100 millivolts equals 1 amp. Get yourself a piece of white tape, a sticker. Mine fell off here. And you may wonder why you see sometimes this black tape. Another good warning for you all. The black tape, you know what I use this for? This, when you put it in your toolbox, you leave it on, these don't go automatically off. You know what happens? Next time you go use it, your battery's dead, or your battery's weak. That's gonna cause a problem. So what you usually do is shut it off, take the tape, and same on the Fluke, by the way. Same exact thing, and that way it doesn't move. That's what I use the tape for. But the little sticker, you could use tape for when you get cut. What do you call that?
Band-Aid.
Not for Band-Aid. What's that other thing you call there? When you get you bandage
Medical
yourself
tape.
up? Medical tape. I'm always brain dead. Too many hours. Anyway, put that right here and just write on it, off. 100 millivolts equals 1 volt. 1 amp, or 100 millivolts equals, or 10 millivolts equals. Just change it to what the Fluke has, and that's right here. And again, a little different on a Fluke. 100 millivolts is up top. That would be here on this clamp. Okay? 10 millivolts, that would be the upper one here. You can see 10 MV, just write that on there, and the one you want highlighted is the bottom one. That's what we're going to use. Now, let's look here. Notice I'm on my scope, channel 2, I have test leads. How many of you out there have their low amp 20 or 40 amp probe? You would have to go over and select this if you own the snap-on version of the amp clamp. If you own that snap-on version, you're going to need to select this or that depending on the setting of the clamp. If you own any other clamp, and again, it's a lot cheaper. You could probably buy 3 of these compared to 1 of those. We just want to make your life easier, get you into current ramping. Go to test lead. That's what I'm on. Hit yes. Now I'm on test lead. I have this set to 1 volt. 1 volt meaning the whole screen is 1 volt. I can read 10 amps. Okay? I'm going to put my amp clamp on. I'm going to zero it. Okay? I'm going to snap the jaws. You can barely see the line going up and down here. Did they see that, Craig?
Mm-hmm.
You see the green line going up and down, up and down. I zero it, and it stays right here at 0. Okay? Now what I'm going to do is I'm going to take this and I'm going to go to the fuel injector. And I'm on the red side of the fuel injector. Look at the amperage on the screen. The amperage on the screen is down, isn't it? It went down, just like it did on the Fluke. Okay? So let's take a second just to hold it there and show you that that went down. Okay? Now all I'm going to do, when you bring it back, Greg, all I'm going to do is take the clamp. You see the top part? I'm going to flip it over, and again, with this clamp, you got to be careful. You hit that button, you may change some readings. I'm going to flip it over, and I'm going to go back to the red part of it, and I'm going to try to stay away from hitting anything. Now let's look at the labscope reading. There it is. My labscope reading actually shows me as voltage goes down, my amperage started going up. And I want to ask everyone again. You look at this and you go, wow, it looks a little different. Well, first of all, we're at 5 milliseconds, so let's close this up a little bit and go to 2 milliseconds for the whole screen. And then we don't see anything, right? If we go to 10 milliseconds for the whole screen, it starts tightening up. If we go to 20 milliseconds for the whole screen, now it's a little tighter. How do we get this excuse me, how do we get the current ramp in the green to be bigger? What do we need to do to make this bigger, to look at it to see if we have a problem? Well, we're going to go over here. Pierre says you reduce the voltage per division so it gets bigger, but the modus is voltage per screen here. Okay? So I'm going to take the setting here, even though it gives you up there, I'm going to take this, and what am I going to do? I'm going to make this smaller. You see how that came up? Now I'm going to even make it smaller. You could see that this came up, and it's telling me over here we're about 700, maybe 800. It's a little hard on the angle. I'd have to really stand up here. About 700. The same reading you had on the Fluke. Now here's a good example, if you look at this, of starter current. In fact, Craig, I'm going to stay up here for a little bit. I'm sorry to get
Not a
everyone
problem.
dizzy.
Not a
Get
problem.
everyone dizzy here for a second. What you have here is a couple of different readings. Number one, we're going to blow this up on the next slide, and this is called cranking amperage. Now you all have a VAT 40 or, a snap-on load carbon pile load tester or one of them. You would never notice how much amperage it really pulls because it's like your meter. It's not fast enough to tell you what the peak amperage was that's right here. You could also do compression on a cylinder with amperage. You can see here we have a couple of humps missing, got a problem. We go over to this one here. This is off a Fluke 98 that I took years back. We can see the amperage goes up, and then what does it do? It goes down. Here, we can see we're doing amperage running. So it's just a little bit different. This is all done with your amp clamp. You can put it around the battery cable. Craig, can you click the next slide, please?
Yes, sir.
Okay, so let's take an in-depth look at this. That's a good view I think they got right there. I want you to know this. Oh, I guess my little box doesn't come up. See if you hit the button one more time. Okay, good. You can't see the settings there, I guess, or at least I can't up on the screen.
It's 100.
100 millivolts, 100 milliseconds. So this is 0, 100 millivolts, 2, 3, so on. Over here, 100 milliseconds, 200, 3, 4, 5, 1,000 milliseconds make 1 second. Let's look at this. When there's no current draw before you turn the key, 0 amps obviously. As soon as you turn the key, 50 amps right there. Your AVR or volt amp tester, starter tester, whatever, would never show you that. Now, what happens right here? It goes all the way up. Every one of these boxes, 1, 2, 3, 4, 5, 6, 650 amps. But what's the time? If this box from here to here is 100 milliseconds, you'd have to divide that up. What's that? 10, 5, probably 5 milliseconds. Then what happens? It goes up, it drops down, okay? And within 3 milliseconds, 300 milliseconds, excuse me, 300 milliseconds, you're 100, 200, down to about 150 amps. Isn't this normal? Your volt amp testers never see this. They never see that. They only show you that. That's just like your meter. That's why current ramping is important. On a scope, current ramping could show you all this, and you could see if you got problems. If we had a bad starter, we may see that a hump goes up, it goes up, it goes up or it goes down. We could have a problem.
Yeah, sometimes that peak current could go 600-700 amps on a momentary basis because of a bad starter.
That's correct. Pierre said it can, momentarily goes up to 600-700 amps. Yeah, depending on the car. That is absolutely correct. Now here we show you something again of a fuel pump. Notice how the amperage, okay, is up top. How do I know the amperage is up top? Because here's channel A, that's 0, and it's going up. I'm also doing this by connecting my leads, 2 leads, to the other side of the fuel pump, negative and positive of the fuel pump. And notice AC voltage looks exactly, or almost exact, like the current ramping. Okay? Now you wouldn't be able to figure out how much amperage that is. Why? Because here 0 is going above and below. You wouldn't know what the current reading is. Like here, we could say 1 amp, 2, 3, 4, 5, 6, 7, 8 amps, and this pump has a problem. Why does this fuel pump have a problem? Notice that this one's up top, this one is almost a box away, then we're back up top again, then we're on top, and then we're falling down again. That's a bad fuel pump. You would not want to do that. And again, if your amp clamp broke and you just wanted to see the signature is basically shown again on the AC waveform that mimics the DC clamp, the current ramping clamp.
What I was saying is on any kind of a motor like a fuel pump, you're looking for an even draw on each commutator leg and no dead legs and no big spikes.
Right. So even draw now, of course this is not a real pump, you can look, it's a little motor, okay? But you will notice on the scopes that you're getting these little humps, okay? What you would really see is when we head back this way to the screen, here's a worn fuel pump. You can see the difference here with the commutator bars worn down. Here's when the motor rotates around and you get nice humps like this. Switch to the next slide. You know, depending on the pump, you could have high little arches like this, and again, we could connect to either side of the pump. If we were doing that AC again, we would go a negative and a positive to do that. You could test the current before the fuse, after the fuse, at the relay where the jumper will show you, or at the ground. The problem is, wherever it's easier is where you'd like to be. You don't want to have problems, do you? Let's click to the next slide, Craig. Here's a bad fuel pump. This was a car I was doing during the class. Notice it went down the ground. We had to bang it with a rubber mallet, and look where the amperage went. It went way up high, every 100 millivolts, 1 amp. A little tough to see from there. 1, 2, 3, 4, 5, 6, 7, 8, I don't know, 9 or 10 amps. And this is after the pump was replaced. Notice a new pump. This was a brand new dealer pump. Not all of these are exactly rounded. Some edges are a little high or whatever. That's okay. What we're looking for is that set of lines and this set of dots here, that they're not out of one little set of dots. If they're out of one set of dots, we're in trouble. Here's another one. Bad fuel pump. Look how bad this one. This was on a Volkswagen. Good fuel pump. Okay. Let's click again.
Well, I'd like to add, new pumps, new motors will be a little hashy until the commutator wear and the brushes
Shut the
wear
kid.
into each other.
Yes, new fuel pumps will be a little hashy. Those were brand new pumps I put in. Here's one here that one of our TST board members years back was in a class of mine, and this is in one of our old TST newsletters. And the problem here was the customer complained that this vehicle would sometimes stall out. It's a little tough to see, but this wire was eaten away. The insulation was eaten away, and what would happen, the wire would hit. This was a problem on GM cars. The insulation was eaten away, and guess what? That would short out. The car would blow the fuse on the fuel pump. The car would shut off. Yet the amperage looked perfect, didn't it? Of course, the fix for this car was replacing the fuel pump. I guess lucky it had gas inside and not all vapors, or Neil wouldn't be around anymore. Click. By the way, in cold weather, up in Alaska and stuff, there's some lawsuits in Canada as well of GM vehicles blowing up. Okay, if you take out your fuel pump relay, you can make a fused jumper wire go to 30 or 87, and guess what? When you go there, you can get the current reading. The caution here is what else is on that relay. Some cars have other things on the relay. Okay, let's move on. Here we have FP to B+. On a Toyota, underneath, if you open that little cavity up, that's still used even on the later model vehicles, meaning right up to the 2008 and so, you go FP to B+ with a fuel pump jumper wire here, or just a jumper wire, and guess what? You put your amp clamp on there, you're going to get your reading. Okay, let's move on. And that's the main relay. If you go in and you test the fuel pump from a connector like this, one of the things you're not testing is everything on that side. Why? You're running voltage in here, you don't know what's going on. And a power probe that we'll be using in a few minutes will show you what you can do with it. Okay, if you want to calculate speed, I really don't bother with this, especially that you have fuel pumps now that are regulated. And what I mean by regulated, they go off VSF, vehicle speed, engine load, and so on. They run slower when the vehicle is actually at idle compared to demand going on the road. But if you wanted to do that, there's about 60,000 milliseconds in 1 minute. The rest is easy. 60,000 divided into the time in milliseconds is the RPM. So here you calculate for this fuel pump, 60,000 divided by 15 milliseconds. And you want to cross 2, 4, 6, 8, 10, 12, 14, 15 equals about 4,000 RPMs that pump is spinning. To me, I don't use that. Again, I just look at a change in the pump speed, and if it has 1, 2, 3, 4, 5, 6, 7, 8 commutator bars, which is the most common, I look for that. Click. Here's a bad fuel pump. You can see the hash up top. You can see that it goes down all the way up. Look at the amperage. 1, 2, 3, 4, 5, 6 amps, hashy, going to ground, definitely a bad pump. Here's when the pump was replaced. Click. Okay. I'm relying on Craig to do click, and I forgot my little clicker thing. So here's the pump, and this is a brand new GM pump, by the way. Brand new, not the greatest. Now, what do I mean not the greatest? You know, you got a little bit off, but it's not out of the box, is it? It's not out of one box. Maybe it has to break in. Now, testing the ignition coil. When you test the ignition coil, we can go to either side. We could go to coil on plug, and notice this kind of looks like that fuel injector waveform, doesn't it? So any type of coil, we could do this, see what the current ramping is. Let's move on to the next slide. Now, here's something, again, we like to show you voltage. When you're checking ignition, it's always easier to go to primary. The coil has usually 2 wires, some of them have 4 wires going in. Find the primary one, and what's happening here, we have the voltage going down. This is dwell, the amount of time the coil is saturating. As voltage goes down, what happened to amperage here? Amperage started going up, okay? This is the firing line. As the firing line went, that means it shot out the spark, the amperage went down. So you can see the buildup, the current ramping is basically all that dwell time. Notice here if we had a problem, okay, notice how the driver does not release when a coil is not properly fired. Look here, you see this? When you got some sort of ignition problem, just like you see here, it doesn't look like that. And again, it's always good to remember this. If this is normal, this is not. Always look for this or something that looks different. This is normal, that's not. Notice with a current clamp, I could just clamp around my wire and look if I have a problem. I don't need to go back probing sometimes. Back probing would mean I'd have to go into the computer, stick a wire into the primary side. We'll show you that in a little bit on the board. Here we have primary. There's the amperage. There's the voltage. Okay? And let's move on again. Just another view. If we have a coil pack like this, or we go in near the computer, you don't need 4 amp clamps, okay? to get a reading like this. This is just to show you, why would we put our amp clamp on the feed side? The feed side is basically going to feed all the coils. So let's say these were 3, 6, 9. If we knew that each coil took 3 amps, which they would probably take a little more, when we hook up here, if we didn't see 9 amps, well, guess what? We know we got a problem, and then we would move the amp clamp to the individual ground that, in this case, the computer is supplying the ground. In other cases, it may be a module. So again, you would hook on to what's common. What's common is the feed side, and then we would go from there. Okay, now here we had a 96 Ford F-150, no DTC stored, complaint, lack of power. First of all, I want you to notice this right here on the side of these coils. You ever notice they have an orange or a purple color? Or you see some white flashing like this one here? This was a relatively new coil, and this coil made the vehicle fail in emission test. Okay? Now look at the difference between the good coil, it's higher, I superimpose this. And notice how the ramping of the good coil goes up. Okay? And it's actually wider. The bad coil starts going up, not as high, right? Not as high, and starts falling down. This is something that you can do current ramping. Where do you hook it up? There's wires that go in there. Just go to the wire. We're going to show you that right on the board. No problem. Okay? Let's click, and we may go to the board on this next one. Okay. Here I have my old Tech 222. We're current ramping. Again, you could see coming up. There, we could tell dwell time from here. And if we're on a coil on plug, this coil on plug, we can go on either side here. Again, some of the newer ones have 4 wires or so. You're going to have to know which one. This, by the way, is a very, very good tool by Mac Vanderbrink called the COP3. This goes into the wire here and then connects to your scope to give you a picture if you want. If you don't see the green light on and no red light, the red light blinks on and off. That would tell you that you got a signal from the module and or the computer. If you didn't see it, you know you got a problem. You also press a button up top here. You press the button, you can cut the cylinder in and out without doing any damage. Let's move on, Craig, and I think we're going to go to the board. I think that was the last. Oh, no. One more. Another one here, Ford Escape, 2005, when I was up in Alaska. In case you were ever up in Alaska, this is called a hitching post. One of the coils here was shorted out. Look at what a good coil has. Do you know what type of coils these are? This is not 3 coils. This is a Ford multi-strike. It goes, it bangs 3 times. The reason why it bangs 3 times, guess why? That's for emission. It only happens at idle. Notice here we have no dwell time, right? Someone shorted out one of the coils. This was a rent-a-car. And they weren't too happy when I brought back that brand new rent-a-car back in 2005 or 4. Look here. And the amperage, how do I know? I got 2 volts per division. That would be 10 amps. Every 1 volt would be 10 amps. That would be 20 amps. This one goes to 20. That's about 18. The first one's 15. So there's my difference with that. Okay. Tony, yes, the wires are primary. That is correct. You would take your amp clamp and go around the primary wire. You're going to see this done in a few seconds right here on the board.
What if there are 4?
If there's 4 wires, obviously you got to check for the right wire. The newer systems are going to be a little bit different, but obviously a coil is going to pull amperage. Anything with a steel bar with windings around it is going to make amperage.
Pierre, want to add anything?
We're going to go over, and
I think I'd like to clarify that. The fact is, if you're on the feed side, that one feed is going to feed all the coils. If you're looking at the trigger side to the computer, you have to go to each one individually.
No, he was talking about the ignition coil, Pierre. I don't think, Tony, were you talking about the fuel injectors? I mean, the ignition coil or the injectors?
Principle is the same. You're going to go to the feed side. You're going to get power. Current's going to be the same.
Right. Current's going to be the same.
Feed side for all of the different, coil packs.
Right. So, in other words, if we had 4 coils, in that example, 3 coils, if we went to the feed side of that, the feed side is going to give us for all of those coils, in this case 3 of the coils. If we knew the expected good amount was 9 amps and you had 6 amps, you're now going to go off the feed side and go to these individual legs that are being grounded. And when you see the one that has less amperage, that's where your problem's going to be. Okay? So let's now go to the ignition coil here. The ignition coil, and I'm going to use the Modus for this, it would be the exact same on the Fluke. And we're going to go to the negative side, which would be the white wire. I'm not going to back probe, but it's just easier for me to do this here. We're not going on the secondary wire. We're going on the primary, the white wire, not the red wire, that's the power. We're taking our amp clamp and we're going around either one of those wires. It don't matter. I'm going to start this up. And look what we have. Well, what do we know right away? My green is down, isn't it? My green is low. So I need to flip my clamp, excuse me 1 second here while I flip it. And I zeroed it, you should always zero. Now look at my amperage. You can see, we can spread this out a little bit. Same thing we kind of seen in the example. Here's my dwell time. As voltage drop, look at my amperage go up. Here's my firing line, there's my spark line right there, the little line, and here's the coil oscillations. So I can easily see what my amperage reading is. I got 0 here on the side. I go up. I'm just changing my readings. And you can see, if we started with 1 amp, I'm looking here and I'm not high amperage on this particular circuit. So if we look, we have approximately 50, got to blow it up a little bit there when you're blind. So we have approximately 1, 2, 3, 4, 5. You got about 300 millivolts. You got about 8 amps or so on that. Okay, so there it is on the Fluke, pretty much the same thing you're seeing there. And our amperage, actually, that's only 1 amp. Let's look back here again. And that is correct. For some reason, the numbers I don't think we're switching before, but right here, 0, 1, it's only 1 amp. We're not putting a lot out on that coil. Most coils are going to be a lot more. This is a test board, just to give you an idea. Let's go back and I want to show you a favorite tool of mine, the power probe.
Also discounted for TST members.
Okay. Yes, actually Power Probe, a good supporter of ours, gives us a very good discount that's passed on to you guys. Now what I'm going to do is I'm going to take this amp clamp and I can either go around this wire, okay, or the other wire. And if you look, I have power going in, I got jumper wires, the little GM or Thexton leads in there, and when I click the motor, look at the amperage right here. You see that amperage is going up? Don't worry about the red. Look at the blue. If I slow the time up, you see that spike when it goes down? If I flip the coil, the amp clamp over, guess where the spike is going to go? That's right, you guessed it, it's gonna go up. So this particular motor, that's 0. Hang on one second, I'm trying to grab it here. Okay. Let me shut this noisemaker off. Now, that particular motor right here, move right into there, Craig. This motor, if I look at my amperage, if this is 0, my amperage went up 1 amp, 1.9 or so amps, because I'm almost at the 2 amp box. Every 100 millivolts equals 1 amp. So that'd be 1 amp, 2 amp, that'd be 3 amps. We're real close to 1.9 amps. You could check every single solenoid on a vehicle. There are many solenoids, whether it's an evap solenoid that typically pulls 3 to 400 milliamps, 3 to 400 milliamps, very small amperage, okay, or injectors that may pull a little more, or an EPC solenoid, electronic pressure control on a transmission, that can pull 5 to 7 amps for approximately a couple of milliseconds, about 3 milliseconds. It's like that peak and hold injector. Remember, that pulled 4 to 6 amps very shortly for less than 6 milliseconds. And the pulse modulated, that pulled 5 to 7 amps, but it did that for a short period of time, less than 6 milliseconds. Anything more than 1.2 amps, again, will burn the computer circuit up.